Math SL functions review mock exam solutions. Um, on this exam, you can't use a calculator. Number one, let f of x equals square root of x plus 4, where x is greater than or equal to negative 4, and g of x equals x squared. X is all the real numbers. So find g follows f, evaluated at x equals 3. So the first thing we're going to find is g follows f, which is actually equal to um, g f of x. Of course, we're going to substitute 3 in for x later, but so the g is x squared, and then the inside we're going to put x plus 4. And of course, if you have square root of x plus 4 in a squared, that's the same thing as saying x plus 4, just the inside part, right? So now we just put 3 in for x, because, here it says we're going to put 3 in for x. And so 3 plus 4 is 7. So our answer is 7. Now we're going to find the inverse function of f, and the way we do that is with the variable interchange. And so let's see. First we'll write f. Y equals the square root of x plus 4. The inverse of this, first we're going to switch x and y, so we write x equals square root of y plus 4. Okay, and then we solve for y. The way we solve for y first is we square both sides. And then we subtract 4 from both sides. And we end up with y equals x squared minus 4. Okay, and that is our inverse function. Okay, let's see. Write down the domain of the inverse function. Let's see, x squared minus 4. The domain of the inverse function is going to be the range of the function. So let's go look at what the range of the function is. So the function f has domain x is greater than or equal to negative 4. What is the range? The range would be that y is, well, look at this. If you took the square root of this number, which is from 0 to infinity, you're going to get a number that is from 0 to infinity. So the range is equal to y is greater than or equal to 0. Okay, all positive numbers is the range for f. So the domain of the inverse function is going to be the range of the function. So we're going to have x is greater than or equal to 0. Does that make sense? Whenever you have a domain and range, if you have a function and you have a domain and range of the function, the inverse function is going to have the opposite. So like the domain of the function becomes the range of the inverse function, and the range of the function becomes the domain of the inverse function. You can see that whenever you take a function and you find the inverse graphically, because you see that the x becomes y and the y becomes x, and that goes also for domain and range. Okay, so that is why the domain is f of negative 1. If you look at this, you might think, hey, the domain for this can be any number, because you can put any number in here and then you get a real value of y out. But the thing is, if you look at the original function, the range was not any real number. It was positive numbers. So the domain for this function has to be just the positive real number also. Okay, now we'll go to number 2. Consider the function f and g where f of x equals 3x minus 5 and g of x equals x minus 2. Find the inverse function f of negative 1. Now we're just going to use variable interchange again. Okay, so these are easy, right? We're going to switch this, 3y minus And then we're going to divide both sides by, or we're going to add 5 to both sides. Add 5, and then we're going to have x plus 5 equals 3y. Then we're going to divide both sides by 3. Y equals x plus 5 divided by 3. Okay, so that's the inverse function f of negative 1. Given that the inverse function of g is x plus 2, find g inverse follows f. Okay, so we know that g inverse is parentheses plus 2, and then we're going to put f inside that, okay? Because basically this means g inverse f of x, right? Okay, so f of x, remember, is 3x minus 5, so we put that in the parentheses. Okay, so 3x minus 5 plus 2 on the outside. If you want to simplify that, that would be, of course, 3x minus 3. 3x minus 3. Okay, next part. Given also that f inverse follows g equals x plus 3 over 3, solve, and then they have this expression here. So this part is going to be x plus 3 over 3. And this part is going to be 3x minus 3, right? This part goes in there. This part goes in there, okay? And, you know, they're creating a relationship here that, you know, normally doesn't exist. When they say solve for this, they mean solve for x, okay? So what is x in this case? Well, we have a pretty complicated thing here, but all we need to do is group x's together. So we're going to multiply both sides by 3, and we'll get x plus 3 equals 9x minus 9. And then we're going to put x's together, so we're going to subtract x from both sides. We're going to put their constants together, so we're going to add 9 to both sides, and we're going to end up with 12 equals 8x. Then we divide both sides by 8, and we get x equals 12 divided by 8, which is also equal to 3 halves, which is our answer, x equals 3 halves. Okay, h of x equals f of x divided by g of x. X is not equal to 2. So we have a rational function, which is a linear function divided by a linear function. And remember that our f of x is equal to 3x minus 5. So h of x is actually equal to 3x minus 5. And on the bottom, it's going to be g of x, which is x minus 2. Okay, oops, that's kind of a mess, isn't it? Okay. Find the coordinates of the x and y intercepts, if any. Okay, so the way you find an x-intercept is that you set y equal to 0, or h of x equal to 0. So let's see. So when is this expression equal to 0? Well, when the numerator is 0. Well, when is the numerator equal to 0? Let's check that out. 3x minus 5 equals 0. Add 5 to both sides. And we get 3x equals 5. And so we divide both sides by 3. And we get x equals 5/3. Okay? So that is our x-intercept. Okay? How do we get the y-intercept? Well, we get the y-intercept by making x equal to 0. Okay? So let's see. What is y when x equals 0? Well, it's negative 5 divided by negative 2, which is equal to 5 halves. Okay, so the y-intercept is y equals negative 5 halves. Okay. Actually, it's positive 5 halves, right? Because negative 5 divided by negative 2. Okay. Okay. So the coordinates of the x and y intercept would be 5/3, comma 0, and 0, comma 5 halves, right? If it's a y-intercept, x is 0, and if it's the x-intercept, y is 0. Okay, so these are the x and y intercepts. Sketch the graph of h for -3 to 7x and from -2 to 8y, showing the asymptotes using dotted lines. Well, that's a good question. Write down the equation for the asymptote. They ask right after that. How do you find the asymptotes? Okay, well, remember that to find the x asymptotes, you just figure out when is there an illegal value, which would be when do you get 0 in the denominator? Well, you get 0 in the denominator when x equals 2. Okay? So x equals 2 is the vertical asymptote. Okay? And what about the horizontal asymptote? How do you get that? Well, you get the horizontal asymptote by putting really big numbers in for x. So let's say you put like x equals 1,000 in for x. So then you would get 3,000 minus 5 over 1,000 minus 2. So you can see that the 5 and the 2 don't really do anything anymore. I mean, it's like pretty much a number that's close to 3,000 divided by pretty much a number that's close to 1,000. Well, 3,000 divided by 1,000 is pretty close to 3, right? And the -5 and the -2 aren't doing much there. Well, you can imagine, like, instead of putting 1,000 in, if you put 1,000,000 in there, it's even closer to 3, right? So the bigger number you put in there, the closer and closer it gets to 3. Of course, it never actually gets to 3, but it gets close to 3. So guess what? The horizontal asymptote is y equals 3. And you can find that by putting a really big positive number in for x or a really big negative number in for x. Then you get y equals 3. Okay, so that's the asymptote. Now let's graph this. So first we said we're going to graph between -3 and 7x. Okay, so let's say here's the origin. And so -3 would be about there. And 7 would be 1, 2, 3, 4, 5, 6, 7. Okay, and here's the origin. And then we're going to graph from -2 to 8 on the y-axis. So -2, 2, 1, 2, 3, 4, 5, 6, 7, 8. So it would be up to there. Okay? And we know that the asymptotes are at x equals 2 and y equals 3. So we'll draw dotted lines there. X equals 2, y equals 3. Okay? And then we're going to mark the points 5/3, 0. 5/3, 0 would be about there. And then the other intercept would be 0, 5/2. It would be there. Okay. And I think one of these is actually negative. I might have done this wrong. Let me see. -5/2 is not negative. X equals 5/3 is not negative. Okay, so I guess that's right. Okay? Okay, now I figured out what I did wrong. The vertical asymptote is x equals 2. I marked it at x equals -2. It's not x equals -2. So let's erase the vertical asymptote at x equals -2 because it's not x equals -2, it's x equals +2. And so we have one point there, and we have one point here, so that means our hyperbola, this is a hyperbola, kind of goes like that. Oops, that was not a good drawing. Okay, so we got this part. We're trying to draw a smooth curve here. It gets closer and closer to 2, but doesn't touch it. And then here, the other side, you would have the other side of the hyperbola, and we're just kind of drawing it. Not really accurate, but let's try to get 1 point for it. So we could put in a number like x equals 3, 4, 5. Let's see which one's easy to put in there. Let's see, if we put x equals 3, that would give us 3 times 3 minus 5, which would be 4, and divided by 1, so it would be 4. So 3 would give us 0.4. So let's see. That would mean that that parabola kind of looks like that. Okay, and maybe